The review for our chapter test will also be a good review for the midterm. We're starting off by writing linear equations. Now this is just half of chapter 2, but these were some of the topics since our last exam. Given the slope and the y-intercept, m and b, remember that questions that could always turn up on the midterm. The variable that represents slope is m, and the variable that represents our y-intercept is b. So again, I'm just throwing in some extra review as we're going along. If we're given the slope and the y-intercept, our goal is to write the equation in y is equal to mx plus b form. And if we have our m and our b, our slope and our y-intercept, we just replace them. Y is equal to 5x plus 3. These are the ones that are straightforward. The answers are right there for us. Let's replace the m with 4 this time, and the y-intercept with a -2. In the last one that I have for our examples, if y is equal to 0 times x plus 4, this cancels out, and I'm left with y is equal to 4. So the first type, or first way of writing a linear equation, is if I'm given all the information that I need. We found out that sometimes we'll be given the slope and a point on the line, so we need to find b. We need to find the y-intercept. So we'll replace what we know. We have y is equal to mx plus b. We have our x and our y. So y is 9, m is -3 times x, which is -2, plus b. We have 9 is equal to 6 plus b, because the -3 times -2 is 6. Let's subtract 6 on both sides. We'll find that our b or y-intercept is 3. Let's write that equation now. I have y is equal to -3x plus 3. One more example of that type. Y is equal to mx plus b is the form. We have an x and we have a y. Y is -3, m is -2, times 5 plus b. -3 equals -10 plus b. We'll add 10 to both sides. This is just simple solving, and this is also helpful preparing for the midterm exam. Now that I have a y-intercept along with my slope, I have -2x plus 7 as my equation. The third way that we were shown how to write a linear equation is when we are given 2 points. We have to rely on our slope formula for this one, which I wrote at the bottom here. So I have my x1, y1, and my x2, y2. Let's find our slope first. 11 minus 5 over my x2, 6 minus 4. I simplify and I get 6 over 2. Simplify again, and my slope is 3. Now I need to find the y-intercept like I did in the previous step, this previous type. I have my y, I'll use the first point, 5 is equal to, we now have a slope, we have an x coordinate, and we're solving for b. 5 is equal to 12 plus b. I'll now do a little subtraction here, subtract 12, and we'll see that b is equal to -7. Just the information we need. We have y is equal to 3x minus 7. one final one here. I'll set it up. You'll solve, and we'll check back and see if we agree during our class. Simplify, then choose either point and find your y-intercept. From there, we had a little discussion on the different forms of a linear equation. Standard form, ax plus by equals c, so I could have something like 2x minus 4y equals 8, and we use that to find our x and y intercepts, which I'll review in our next class for the midterm. I have my slope-intercept form, y is equal to 5x minus 1, where I have my slope and my y-intercept I can identify. And then we had something called point-slope form, y minus y1 is equal to slope times x minus x1. Okay, and we went over all those types. The last particular topic that we spent our most time on recently was our linear inequalities. We first tested out possible points by substituting in the x's and y's. Once we substitute in those values, we stop and see whether it's a true statement. 8 minus 3 is 5. Is 5 greater than 9? That's a false statement, so this is not a solution. Our next, let's replace x with -2 and y with 5. We'll simplify and we'll read that statement. I have 8 plus 10. Well, 8 plus 10 is 18. 18 is less than or equal to 20, so this is a solution. And as I did on the previous slide, I'm leaving this last one for you to set up and solve. The answer we'll review in class. And the final topic that will be on this test, try to keep it as few topics as possible, was the graphing of linear inequalities. If you recall, we had to graph using the slope and y-intercept. We had to decide if our boundary line should be dashed or whether it should be solid. And then we had to test out the point 0, 0 to determine whether we're going to shade with or away from the origin. One quick example, if I had y is greater than, greater than -2x plus 1, and I go and I do a very rough sketch here. I'm going to tell you that your m, or slope, is -2. Your b, or y-intercept, is 1. Always start graphing at your y-intercept. Use your slope to find additional points. Go down 2 and over 1. We're going to go down 2 and over 1. We have to do the full length because we want to break this into 2 parts. This requires a dashed line. Okay. And then from there we have to decide where to shade. Well, if I have 0 is greater than 1 is a false statement. That means that the origin is not part of the solution. I will shade everything on the opposite side of the origin. And there you have your review.